Okay, so for now part 2, it's now projected horizontally with the same, but from same initial position with speed u. So that means this bit no longer going to be like that. It's now going to be u. And we ought to find out the set of values for which the string does not remain taut. Well, it will definitely remain taut whatever happens up to here. It's up to there. It has to. It can't go slack at that stage. But it could go slack anywhere here. And if it gets up to here, it will have to stay taut. So it's got to be taut all the way around there. So it's when it goes somewhere between here, when theta is pi by 2, and up here when theta is 0, it's between there that the problem occurs. It's going to have to be fast enough. If it's going to get up to here, it's going to have to be fast enough to get to here. And otherwise, it's just not going to be able to get up to that bit there. So let's just do some normal things. First off, we want to do initial energy. So we're going to do total initial energy equals total final energy. And so we've got potential energy plus kinetic energy, and again potential energy plus kinetic energy. Starts off with nothing plus half mu squared, and that's going to equal our final energy, which is going to be mgh, which will be a plus a cos theta plus half mv squared. And I'm going to obviously divide through by m, so the m's disappear. I'm going to times by 2, so I get u squared equals 2, take out a factor of a, 2ag, and that'll be 1 plus cos theta plus v squared. And so v squared equals u squared minus 2ag, 1 plus cos theta. That's a good start. Now I need to resolve inwards. Same as we did before. So resolve inwards. I have resultant force equals mass times acceleration. I suppose I should put my forces on here. mg and t. And so we get t plus mg cos theta as before equals mv squared over a. That's what v squared is. So I get t plus mg cos theta equals m times by u squared minus 2ag 1 plus cos theta all over a. And I'm to multiply this bit out, so I get t equals, because that's what I need, that will be mu squared over a. That's the first bit. And then minus 2mag over a. And then minus times by 2mg cos theta, or 2m times ag, so 2mag cos theta over a. And then I've got to take away mg cos theta from both sides. And that says that t equals mu squared over a. Minus a's cancel out there, minus 2mg. Here a's cancel out, so minus 2mg cos theta, and 9 minus another mg cos theta. And so we get t equals mu squared over a minus 2mg minus 3mg cos theta. And we want to see when mt equals 0. So when t equals 0, we get that bit. We get mu squared over a minus 2mg minus 3mg cos theta equals 0. And it could come slack at the top if its speed isn't fast enough. And it says, well, find a set of values for which the string does not remain taut. So we want to find out when it does become slack. I don't like these negatives. So when it does become slack, and it becomes slack if u is beneath the speed required at the top. So we're going to sub theta equals 0, and that'll say that mu squared over a minus 2mg minus 3mg, because cos theta is, if theta is 0, cos theta is 1, that equals 0. And that'll say that mu squared over a equals 5mg. M's cancel out, times both sides by a, so u squared equals 5ag, so u equals the square root of 5ag. And so here, so u will be less than root 5ag, because if it's more than root 5ag, then it's got enough energy to get to the top there, and it's all going to be cool. So done that bit. I'll do the next bit down here. Not much room. The other bit, or if theta equals pi by 2, because I say if it's more than pi by 2, it will certainly stay taut. So we got mu squared over a minus 2mg minus 0 equals 0. 0 because cos theta equals 0, and m's cancel out, and that gives me u squared equals 2ag, and so u equals square root of 2ag, and the u will have to be bigger than that, so u must be greater than root 2ag. Otherwise it won't get up to this bit here, and it will stay taut, and it's got to go slack. So u's got to be above this and below that, so I would write down that root 2ag is less than u, which is got to be less than root 5ag. And if that's the case, then the string will not remain taut, i.e. it will go slack somewhere between theta is pi over 2 and theta is 0, somewhere there. And that's the second part of 5 done.